Okay, hello, this is Dr. James, and today I'm going to talk about this signal generator kit. I thought initially it was a pretty good idea. It's got Bnc outputs. You can control the amplitude and the offset with these potentiometers. There's a lot of things I don't like about this. It's a simple kit to assemble. It was a neat idea, but it really didn't quite come through the way I thought it would, because I've been building these other kits and with signal generators and then building frequency counters to go with them. And this one supposedly had everything together in a single kit. You know, it has a display that tells you the frequency and generates the signals, so it's like 2 for 1. But it actually has some severe limitations, which I'll go through, build this device from scratch and talk about testing it and some of the limitations. Okay? Anyway, let's get started. Okay, here's an interesting box. I think this might be some capacitors that I ordered. Let's see. Connectors. Nope, I guess not. Oh, you know what these are? Oh, these are, I think, digital signal generators. Oh, this should be interesting. I'll have to build up one of those. See how those come out. Okay. Oh, this should be fun. Okay, so here's our kit right here. And let's take a look at what's inside of it. Oops, I may need a razor blade to cut that. Okay. Okay. An LCD screen, some kind of potentiometer, Bnc, plugs, resistors, some posts, a chip, and a plug. Okay, and it looks like some switches or something. And there's no directions with this. Hopefully we can do all the board just by doing this whole project just by looking at the board. Looks like the board might be labeled. Okay. Okay, it looks like this group is about 10K, and so we'll populate these next. Okay. Okay, so like I said before, with these kits, I always recommend getting more than one, because one is none, and they're like a Chinese puzzle. So I populated all the ones on the board because there's no directions with this kit. Where they said 10K, there seems to be one more up here, but there's no resistor symbol. I'm assuming it's between those 2 points right there. But I'm going to hold off on populating it until because there's some other vias. There's another via right there. I'm not sure what that's for. And so there's seems to be 3 10K resistors left, and only one possible slot for it to go in. So I think I'm going to go maybe to the 20K next. Just a bunch of 20Ks and try to populate them up. And just try to populate everything and see what's left over maybe. Because this is... these kits are a little bit nebulous. Okay, so let me find the 20K and we'll try to populate that up. Okay, so here is a bunch of resistors, and they seem to be measuring as 20K. So let me populate those up next, and then we'll see if we can find the other resistors and put them into place. Okay. Again, this is where the 10K ones are that I've found so far, and there possibly is one 10K up there, although it's not clear where that should go. Okay. Okay, again, I have one resistor left over, the 20Ks, which I don't like. Usually they come out to the exact amount. Remember, there was one 20K down here, and all these were 20K. And I'm not really seeing any more 20Ks up on this board. So I'll just move on to the next batch and try to fill things in and see what's left over. Okay. 220R. Okay, so we got a few more resistors. So I don't know if there's enough resistors though. Do the odd ones though, but let's start taking measurements and we'll see what fits where. Okay, this resistor here is measuring almost 12K, and I think I saw a 12K on the board, so let's populate that one up. Okay, right about there. Okay, so there's the position of the 12K. And as always, when I'm populating these up, I bend the leads outward so the resistors don't fall out when I'm moving the board around. Okay, and let me look for the next one, and we'll see what we can find next. Get it populated up. Okay, so this resistor looks like it's measuring 218 ohms, and I think I saw a 220 ohm resistor up here at the top of the board, right there, and so we'll stick that guy in there. Okay, okay, again, there's the 220 ohm resistor. Okay, and we'll try a couple more and see what these are. Okay, so these are measuring 100K. And unfortunately, there's two slots for 100K resistors right here. So we'll populate those up, and we'll see what's left over. Actually, okay, yeah. Okay, my worst nightmare has come true. There's a 100R resistor spot right there, and I can't find any other resistors. These are the spare 10K ones that I had. That's a spare 20K one. And I don't know, I've ordered 4 of these kits, so I may try to look in one of the other kits to see if there is a stray 100 ohm resistor to make sure that it is supposed to be 100 ohm and that's not a typo or something, God forbid. Jesus. I don't know. So it's one of those kits where you got extras of some things that you shouldn't have and not enough of some things you should. Remember, one is none. So, okay, so let me break open another kit and see if I can check through the resistors and find a 100 ohm. Make sure that that is a correct value. Okay. Okay, so I broke into a second one of these kits and I started going through the resistors, and I'm suspecting this one may be shy on some critical components too, but look here, here's a 100 ohm resistor, which was not included in the first one. So I think I'll snag this one from the second one. I mean, resistors are cheap, but when you're trying to figure out, you know, if this kit is right or not, it's really good to have the right parts there. I mean, I could probably search through my reserves and replace that 100 ohm resistor as long as I know that it's really supposed to be 100 ohms and not some kind of typo or something. So it looks like they did include a 100 ohm resistor in the second kit that I looked at. Right there, 100 ohms. Okay, so we'll populate that one up, and I don't know, this kit is starting to get me worried. We'll see how it turns out. Okay, so there's the position of the 100 ohm resistor right there, and I don't know, maybe I'll just go ahead and stick that 10K in up there. I think it's supposed to go between those 2 points. I don't know, it's not really clear, but definitely something's got to go there, and it does say 10K, so I guess we'll try to believe that and just stick a resistor between those 2 points there, and hopefully that doesn't destroy something. Even more wonderful, those holes aren't really far apart for the resistor to fit in there very nicely, so I hope there's something that goes in there. And there's a third via hole, I don't even know what that's for, so try to look at the diagram up here because I'm trying to figure out how the LCD goes on. So I think I can figure out how the LCD goes on based on that, but it doesn't really show a clear picture of... Oh, wait, you know what? Oh, I see. Maybe from that diagram, that's a potentiometer up there. That's why there's 3 holes. Oh, okay. See that? That looks like a potentiometer sticking up. And that's why there's 3 holes. Let's pull this guy out. I think there's a little potentiometer in there that might be 10K. Let me see if I can find that. See, there's a potentiometer in that bag. Wow, this is really questionable. Okay. So we'll see if that one fits in that hole and if it's 10K. Okay, well, the writing on it says 103, which I believe means it's supposed to be 10K. It's reading about 8.34K. And it looks like it will fit into that 3-pin socket. So let me, this 3-pin hole pattern. So let's try sticking that in there, I guess, because I don't see any other place where this would go. And it looks like from this picture here, that could be where the potentiometer goes, is right up on the top, up there, right above the LCD. Okay. Okay, so I put it in there, and it looks like it fits in nicely. So that is probably where that goes. So it looks like I do have an extra 3 10Ks and an extra 20K, and I'm down 100 ohm resistor. And I look over the board, I don't see any other missing resistor sockets, so maybe we'll go to the capacitors and pray those work out a little bit better than the resistors did. Okay. They also gave us this little bag here. Let's see what's in here. I think this is where the I'll get this thing out. We got some kind of possibly push switches. Let me see. I think these are, yeah, momentary push switches, which it looks like there's supposed to be 1, 2, 3, 4, 5, 6 of them. Okay. And okay. 1, 2, 3, 4, 5, 6. Okay. And it looks like we have a crystal oscillator that goes into the circuit and some standoffs to hold the LCD display up above the circuit, and about 4 capacitors. And let me try populating up the capacitors next. 2 of them should be 22 picofarads, it looks like, and the other one should be 104. Let's see what this is. Okay. Oh, come on. I think that's a 104. I don't know if you can read that. Yeah, that looks like a 104. So the bigger ones must be a 104, the lighter brown ones, and the smaller ceramic looking ones look like they have a 22 on them. Okay, so let's go ahead and populate those up. Okay. So it looks like the 104s go up here, like so. Okay. And there's a 104 over here as well. Okay. And the 22 picofarads. Looks like they go. Let me spread these out a little bit more. And here on either side of this crystal oscillator. Come on. There's one 22 picofarad there. And the other one, let me just bend these apart. Looks like it goes over here. Okay, so the 104 is here, and the 22s are here and there. And I'll bend the leads out in a second, but while I'm on a roll, I'm going to assume that the center thing is the crystal oscillator, and it says 16M, so I'm assuming that means 16 megahertz. Let's see if this thing says anything on it. It looks like it's 16.00. You can read that. It's really faint. Okay, so that must be the crystal oscillator. And the crystal oscillator, I believe, goes right here. Okay. there. The Crystal Oscillator, the 22 picofarads, and the 104s. Okay. And so I'll probably bend those leads out. Maybe I'll populate these things up next. I need to check to see which direction they go, but they probably go like that. Okay. And then pretty soon we should be ready to start soldering these things in. Well, actually, I want to put these there's a couple sockets that go in, and a header here. Okay. Okay, so it looks like these momentary switches have a rectangular footprint, and so they only go one way. And when I tested these before, they were like, what'd you call it, double throw. So they have two different leads that go across. Well, I mean, with other projects, I've seen that. Hopefully these are the same, and it doesn't matter whether they're right side up or upside down, because I see no orientation marks on them. Okay. And like I said before, I think this header is going to go kind of over top here, so that you're probably going to have to, let me get some of these parts out. Okay, again, looking at the picture up here, it looks like this header, the pins are at the top up there, so they'd be at the top here, and they would overlay, basically the header would go over top of the crystal oscillator. And I believe what we're going to have to do is put one of these plugs here into that position, and then this header will have something you can plug into that, which I guess makes it nice. Then you can unplug the LCD display. But it's, and see, these plugs will plug into that, and you just solder them underneath of this guy. So I think that is the next step. And then there's two Bnc outputs, and there is two potentiometers to control this. And it looks like one is a 50K and one is a 1K. So I'll get the potentiometers out and try to measure them and see which one goes where. Okay. Okay, here's one of our potentiometers, and here's the other one. I have it on the voltmeter, and this one's measuring about 50K. And if we look at the back of it, I'm going to be careful how I unhook this because I don't want to bend the leads. But, there, come on. There is a designation of, it looks like B50K on there, right down here at the bottom. And so I believe that would go into the 50K spot right here. And I'll just measure the other one, okay, to make sure it's 1K. And let's get the rest of these things populated up, and then we can start soldering. Okay, and it looks like the other one does measure up to be about 1K. So let's put that into the board up here. Okay, so we got the two potentiometers in there. I'm going to put the plugs and the sockets on here, and that header, header kind of fell out when I flipped it over. Maybe I'll solder that on after I get the other critical components in. Okay. Actually, maybe I'll wait to put the sockets on and stuff until I get these other things, because I don't want stuff falling out. I'll try to get this soldered up, and then we'll put on the rest of the parts and put it together and see how this thing works. Okay, so we got our soldering iron here, and we got it all heated up, and here's our circuit. And I guess let's flip her over, and we'll start soldering these leads on here. Okay. And let's go through and solder all these on, and then we'll mount the rest of the components, and we'll test her out, I guess. See how it works. Should be interesting, huh? Okay. Okay, so I just finished soldering it. Let's look at the solder joints on the magnifying glass. And I think they look pretty good. Oops, looks like I missed a couple. Okay. Let me solder those up, and then I'll start clipping these leads off. And I was using some dikes, but I did find that nail clippers work pretty good too. Let me get those last two soldered up, and then we'll clip these leads off and go on to the next part. Okay. Oh well, I guess I couldn't find the nail clippers. They seem to have disappeared around here. Oh gosh. Okay. So let's just use the dikes, I guess. I did find the dikes. For some reason they don't seem to cut as close as what I like, but... Oh, come on. Okay. I'll just go around and cut all these leads off, and we'll mount the rest of the components. Okay, so it looks like we have all the leads clipped off. Let's just examine it one more time under the magnifying glass. Looks like they're all pretty good. Might need to reflow. Well, maybe those are okay. Maybe that one. Okay. So let's go on to the next step. We'll populate the sockets for these chips that we're going to stick in there, and the Bnc outputs. Okay. And oh yeah, I'll put this header up here too. Okay. Okay, so here's the rest of the parts that we're going to put on. The Bnc jacks. Here's the header here. And it looks like the chips and the sockets are all taped up in here, so let me get a razor blade, I guess, and cut this and take it apart here. Come on. Really? Okay, there's a little IC here. Try not to bend the pins. Okay. And there's a big IC. I can get this out of here. Just want to put the sockets on right now. Okay. Okay. There is, come on, there's our two sockets. We have an 8-pin and I don't even know what this is. So if you look on the board, see there's a little notch there, and there's a notch on this socket. See if you can see that. There's a notch on this side, so that tells you the orientation of the pin. And we'll get that socket in there. And again, there's a notch right here pointing down, and there's a notch on the 8-pin one. So let's get those positioned into place. I'm probably going to have to fiddle with the big one because the pins aren't going in. Maybe some of the pins are bent out a little bit. Well. Okay. Let's see. Looks like all the pins are okay now. Come on. Get that. There's lots of pins. It's hard to get them all into place, I guess. Okay, there we go. So we got these two sockets seated. And what I'll do sometimes is I'll bend the pins outward on the bottom so that the socket doesn't fall out. I may have to solder this in 2 batches, but here's our Bnc connectors. It looks like they go down here. Get the pins bent in the proper position. Make sure the two tiny ones are the electrical ones. Those big ones are just to hold it mounted in place. Okay. Get them bent out a little bit. tiny ones in first. Okay, and I think we're all ready to start soldering this thing up. And we'll look at those in a second. Okay, so we got the circuit flipped over, and let's see how we can do this. Okay, so here we'll just start soldering the backs of these pins. There's like a bazillion of them. Okay, now let's go ahead and solder those, and then we'll move on to the next step. Okay, I just finished soldering these two sockets on there. Oh, let me solder the Bnc things too. Okay, so I have the header soldered on, and the Bncs. Let's just take a look at the solder joints under the magnifying glass here. Okay, looks like those solder joints are good. Not seeing any solder bridges on the big IC or on the little IC. And here's the header up here, and I think that one looks pretty good too. Okay, so let's go on to the next step, I guess. Out of curiosity, I've been trying to characterize what kind of ICs that they're using in these projects. I don't even know if I can read that. Oh my god. Okay, I'm going to have to look at this more closely to see if I can figure out what that chip is. Okay, I was looking on my other kit, because I bought several kits, like I recommended. And this one looks like it's a LM358P. I believe that's what it's reading. Okay. It's hard to see. Okay, it did have a Texas Instruments sign on it, and it's a LM358P, which is a dual op amp. Okay. And looks like voltage can be from 3 to 36 volts. It has a unity gain bandwidth of 1.2 megahertz. I guess that's not too bad. And typical op amp circuit, and if we go down, because this is the dip pin or 8 pin, looks like it's got out, in, minus, in plus, and V minus. Okay, V minus and V plus are the power supply. Out, in minus, and in plus. Okay, so there's one op amp. This is out 2 on this side and out 1 on that side. And there is the locating pin. Remember, that goes toward the notch. Okay, I guess we'll see what the other circuit is that we're dealing with. Okay, again, this one's a little bit difficult to read. But I think it says J35459R for the middle number. Sometimes that's the number, sometimes it's the other numbers. I think the top one is like the name of what it is. AT Mega. Okay, so it's an AT Mega. Okay, that's probably what it is. It's an AT Mega, which is a microprocessing PIC controller. GA16A, something like that. I'll see if I can find what that is. Okay. Okay, so here's the AT Mega 16A. And let's see here some of the specs. It looks like it can go up from 0 to 16 megahertz, which is what our Crystal Oscillator was at. Power consumption 3 volts at 1 megahertz. Okay. And that looks like our chip. Okay. Anyway. Let's see, here's the pin outs. Lots of pins. And I came to it from this page, and that also definitely looks like our chip here. Okay, so that's probably what it is, ATmega 16A. So it's some kind of PIC processor that's been custom programmed. Okay. Okay, so let's, I guess, put these into the sockets. Okay, so remember our notch on our 8-pin is pointing down, and we have a little dot here that should be pointing in the same direction. So basically the dot is on this side of the dip chip, and usually I have to squeeze these a little bit to get the legs that come in that go into the sockets. You want to be careful when you insert these into the sockets that all the pins go in and that none of them bend outward. Okay. Also make sure it's in the right direction. The little dot should be on the same side as the notch there. And again, here is our ATmega. I may have to bend these pins in a little bit, just squeeze them just a little bit to make sure they fit into the socket. It's got a lot of pins to make sure that they fit in there. And there's a notch on this side, and it goes toward the notch in the socket. I'll get that lined up. And I may have to put the camera down for this one because there's a lot of pins and I don't want to bend them. But you want to just make sure all the pins are lined up on both sides, and that you don't bend them, and then carefully insert it into the socket. Okay, I'll just look at it under the magnifying glass and make sure none of the pins are bent out. Everything looks good. Looks like they all went into the socket properly. It's facing the right direction on both of them. Okay, then maybe I'll just solder up the LCD on the top, and then we should just be about done. The LCD should plug into this socket there. Okay, so here we have our LCD and our little header pins. And I'm going to actually take the short side of the pins, I think, and solder them in like this, and leave the longer side ones to plug into our socket over here. Okay, so I'll get my soldering iron out and start soldering these headers on, and then we'll plug her into that and put the standoffs on, and then we should be ready for, looks like it requires a complicated power supply with plus 12, minus 12, and plus 5 volts. Okay. Okay, anyway. Okay, so I've soldered this header thing on, and before I plug it into there, I think I'm going to put the standoffs into the circuit, so they'll be all ready in there, and then I can just plop this down, and I'll probably have to solder some pigtails onto this to test it out for the power supply. Okay, well, let me get the standoffs out and I'll put them on. Okay, again, the standoffs were inside of this little circuit. And for some reason they gave me 3 standoffs and 4 screws. And I believe the standoffs, I'm going to stick them here and there. Let's do that, I guess. Put the screw through the circuit like that. And screw the standoff on that side. Okay. And then I'll put the other standoff over here, and I'll just hold off on the 3rd standoff because I don't have enough screws for that, first of all. And it seems like this kit is sometimes supplying extra things that you don't need and not supplying things that you do need, like that 100 ohm resistor. Okay. Okay, so we have our 2 standoffs, and I guess let's just plug this into our socket up here, get it lined up straight, and kind of work it in. And it looks like these holes line up good. Not sure where my screwdriver is, but we have enough screws to finish this, and then we have, of course, 1 extra standoff in this particular kit. Okay, well, I gotta find my screwdriver and then we'll screw that in. Okay, I found my screwdriver, and of course it's magnetized now. Come on. It's actually pretty strongly magnetized for some reason. Come on. Okay. There we go. Screw that screw in. And get this one lined up. And screw that one in. Okay. There we go. And so we have our two standoffs down here. And here's what the top looks like. And hopefully this thing is assembled properly. Got our little push buttons here. And here's the back side of it. Okay, so push buttons here. Some kind of controllers, amplitude and offset, I guess. That's interesting. Okay, so there's no frequency setting. Okay. Bnc outputs. Usually I like to have a frequency dial. So it looks like amplitude and offset and whatever these other things are. Some kind of controller buttons. Okay. So we'll have to solder some pigtails onto here and get a power supply that's got +5, +12, and -12 and ground. Okay, well. Okay, so our signal generator is about ready to be tested on a power supply, but like I said, it has a complicated requirement for power supply. It needs a +5, +12, a -12, and a ground. Okay, and so I got some wires here. You would think they'd provide some kind of header so you could solder to the header, but looks like there's no header there. And these wires are a little bit too thick to go through those holes because they're very small holes. So I'm going to have to cut down some of the strands of wire, and I'll get those wires in there and try soldering them. Okay. Let's see how that goes. Okay, let's solder these wires on. I have my soldering iron ready. And I think I'll try to solder the green one in for the ground. And there we go. I'll just clip those back. There's the first one. So let me get the rest of these wires soldered on, and then we'll test this thing out and see how it works. Okay. Okay, and so I got these things soldered on, all the wires. Of course, you want to clip them back so they don't short out with each other. Make sure there's no wires in the bottom. Check the solder joints, make sure they look good. Make sure there's no shorts. And I think this thing might be ready to test out. Okay. Okay, so I think I found a power supply to power this crazy device. It's got +5, +12, -12, and common. And I was just checking the voltages because it's always good to check the voltages before you plug something in, just in case. Okay, this yellow one is 5 volts. Okay. Red one is +12. Okay, see, I got the red lead here. And here we got the black lead, -12. So it looks like all the voltages are correct. You know, you could always have a bad power supply. You always want to double check everything before you put power on something, because you will ruin something if the power is not right. Okay, so let's hook it up and see if this thing turns on and see what it does. Okay, I think I got all the leads hooked up properly and I double checked them, and here is the moment of truth. The LED lights up. nothing else is happening. Oh man. Let me fiddle with this thing. Of course. Okay, actually, what I did is, we have this potentiometer back here, and I just twisted it some. See, if it was twisted too much, you can't see the LCD display. So if you fiddle with this guy back here, it will come in pretty nicely. Okay. So it says a sine wave on 900 hertz, and oh, looks like I'm left. Okay, so I'm pushing these buttons down here, and it says it's changing the frequency. And for some reason I've turned it off. Okay, the start one, I guess, the center one turns it off and on. And I don't know, I'm going to have to fiddle with this some. Hook it up to an O-scope and see what's going on. Let me take off, I guess there's a plastic cover over that. Okay. See if I can see that a little bit better. Okay. Let me hook it up to an O-scope and we'll see what's going on here. See if anything's happening. Okay. So we have this set at 200 hertz, and here is our sine wave. It's got some kind of weird glitchy thing in it. I'm not sure why that's there. I'll have to see if I can figure out how to change this a little bit better too, because I'd like to have better increments than that. But looks like it's putting out something, and this is the Dds output. There's also a HS output. I can try that. So there's two. There's an amplitude and there's an offset. And if I fiddle with the amplitude, it looks like I can make the signal smaller. It's still got that weird glitchy thing. So the amplitude is this potentiometer, and the offset is on this one. So I can shift this guy up and down until it hits the rails, and it will actually clip if it's too big and I'm shifting it up and down. It will put it up to max, and see how it clips when I shift it past the rails. Okay. So there is, looks like it's working, it's doing something. Oh, what happened? Oh, it turned off. Okay. It says 200 hertz, but it looks like it's at a higher frequency now. So I'm not sure what's going on there. Okay. So, as I said, the last one was at 200 hertz, and it looked a very different frequency. Okay. Let me fiddle with this and see what's going on. Okay, so I think I figured out how to work this crazy thing. So I guess you gotta, see it says off. When it's off, you can hit left or right to change the frequency. There's a left and right button here. And then you have to turn this, there's no signal coming out of it when it's off. So then you turn it on and the signal comes on. But you can't, it seems like you can't adjust the frequencies while the signal's on. So you have to push the center button, turn it back off again, and the signal goes away. And then you can change the frequency here. And I guess we can go up in increments of, That's 100 hertz. Okay. And then we can turn the frequency back on. Okay, then it's a really high frequency. So we're at 2 kilohertz, and I'll have to change the time scale to look at that more properly. Oops. Okay. So that may be 2 kilohertz. That's 500 microseconds per division. 200 microseconds per division. Okay, it's still got that weird glitchy thing with the sine wave. Okay, so we can turn this off. Let's go up to high speed 1 megahertz off. Okay. Sine wave, square wave. Okay. So a triangle wave, sawtooth wave, reverse sawtooth wave, ECG. I don't know what that is. Okay. Oh, some kind of funky waveform. Looks like something you'd see on the heartbeat. I don't know why anyone would want that. Okay. ECG. Okay. Frequency step. Noise, random. High speed 1 megahertz off. Okay. Let's do square wave. I like square wave. I want to see what that does. We'll turn this on. Okay, there's our square wave. Okay. And turn it off. Let's try triangle wave. There's our triangle wave. It's still got that glitchy thing. I wonder if there's something wrong with the circuit. See, it's got that little glitchy step right there, right near the transition. Maybe there's something wrong with the op amp or something. I don't know. Okay. Turn that off. Sawtooth. Okay, there's a sawtooth, and again, it's got that glitchy thing in there, so it makes it look like a double sawtooth. For some reason, I'm not sure why. There's just a problem with one of the solder joints on this board, or problem with the design, or what? I don't know. Okay. Reverse sawtooth. There it is, and of course it's got that glitch in there again. Okay. We've already looked at that one. Frequency step, noise, random, on. Okay, wow. It's just a bunch of random jumping around. So I guess it does kind of a random noise thing. High speed 1 megahertz. I turn that on and I'm not seeing anything. Okay. Let's see how fast we can go with this. Okay. So it looks like we're going up in increments of 100 hertz. I'm not sure if we can do smaller steps. We're at 4 kilohertz. Okay. And the up and down seems to change the mode. So I'm not sure exactly how, if you can do smaller steps than 100 hertz, but let's see how far we can go up. Okay, 16. So that's supposedly 22 kilohertz. Let's turn that on and see if we can see the signal here. Let's change the okay, so very interesting, huh? That looks like a sawtooth at 22 kilohertz. That's supposed to be a square wave. That doesn't seem so great. Let me try the other output. There's two outputs here. That's a DDS output. Oh, come on. Put it on the left output here, which is the HS output. And, well, not really seeing anything coming out of that one. It's not triggering or anything. We have the amplitude all the way up. I don't know. Okay, let me put that back on the other one. I'm going to set the camera down to do that because it's a pain in the ass to unplug this thing. And we'll fiddle with this some more. Okay. Okay, so I brought it up to about 45 kilohertz on square wave, and this is what it looks like. I had to increase the amplitude, or the scale size, because the amplitude drops so much. It's really small and jittery. It looks really junky. I had to increase it because it was on the 5 volt scale before, and now it's on the 1 volt because the amplitude drops so much. It's still putting out a signal, but it's greatly decreased. The bandwidth is definitely not there. I'm not sure if it's a problem with me soldering the thing, but there wasn't too many places you can make a mistake in soldering. Or it's just a bad design on the board. I don't know. Maybe I'll have to build another one and see how it comes out. But definitely it's saying 45 kilohertz, and it's really not putting out that type of signal. It's really terrible. Okay. Okay, here's the max signal. 65 kilohertz. I can't go up any higher than that. And the output is even smaller, and it's not got a stable baseline. It's just really jittery, really junky looking. I'm going to take it down to where I think the bandwidth of this signal generator is, and then we'll see what the max output of this guy can be. I like the whole idea of it having a frequency counter built right into it, and the thing being cheap and everything, but it doesn't seem to really be performing the way they claimed it should, the way I think it should at least. Okay. Okay, so here we have the device set at 10 kilohertz, and it is still looking like a triangle wave. I'm going to bring the frequency down some more, and we'll see exactly what that looks like. Okay, so here it is set at 4 kilohertz square wave, and that's still not super great. I mean, the rise times are about as long as the flat top, so I would say this is still not really capable of doing that type of frequency for some reason. Maybe the op amp is too slow. It doesn't have the gain bandwidth to do this, be my guess. Anyway, so it doesn't, maybe it can have the digital output that speed, but the analog output is not able to quite do it. 4 kilohertz, and it's still really not that great. Okay. Okay, I've set it down to 2 kilohertz, and there, I mean, it's really still not great, but I would say that'd be about the limit of what you'd want to use it at. The flat top is at least longer than the rise and the fall time, but it's not too great. Okay, so I don't think I can really use this for a lot of the stuff I wanted to use it for. This is just something for very low frequency, we'll try some of the other waveforms here. Triangle. Yeah, see, it's got some kind of weird glitchy thing, and maybe I'll assemble the second board, but it's really not looking so great here. I mean, it's possible it could be a bad solder joint someplace on my part, but it's very possible it could be just a bad design. Okay, let's see. Noise. So everybody loves sine waves. Okay. There we go. Sine wave with that glitchy thing in the middle. Anyway, I would have to say, all in all, this board is a very big disappointment to me, because I really was hoping to have something with a frequency counter and signal generator, high quality signal generator in a single board, and this does not seem to be cutting it. It does not seem to really fit the bill. Okay. Anyway. See if I can get a good view of that. So, for very low frequencies, I don't know. Maybe I'll go through the board and see if I can find some problems with it, but I kind of suspect it's just kind of the limitation of this, just a bad design. And even there's parts missing from this kit and stuff, so it just didn't really seem that great. Anyway, this is Dr. James, and thanks for watching.